All right, so let's get started. I want to start with the quiz of last week. Solutions for the quiz from last week. Because last week I didn't have the digital copy, so we didn't have a chance to discuss. So the first question actually had a typo. I fixed it now, but you were not graded based on this. But basically here in the question you had these variables x, y, z, and there was this function f that actually takes the global value of x and changes with y plus z. And then we first run f of x. Okay, apparently there is still a typo. There shouldn't be x here. But anyway, so you call this function f, and then what happens to the true value of x when you say print x? So do you remember? Do you know the answer to this? B, right? Yes, because we are modifying the global x. So the second question, we are given this function where c has a default value of 7, and we print all the values. So if we input 2, 3, 1, then what will be the printed values? Okay. Yes, it should be 2, 3, 1. Okay, again, it shouldn't be assigned to output. We just call f of 2, 3, 1, so it should print 2, 3, 1. So don't worry about the output here. Okay, so for this one, we have these keyword-based variables where toast and ham are 0, and we print the values. So in this case, if we so we have the positional variable spam as 1, and x is 2. So toast is, we change the value of toast to 1, and ham is still 0. So it will print 1 to 1, 0. D here. Okay, so for this one, we have the variable x, which is spam, and we have a function, and we have a local variable x here, and then we print x, which should print the local variable x first, which will be ni, and then so we call this function that actually prints the local x, and then when you look at the original value of x, the global value of x, then it will still stay as spam. So it will be ni on the first line and spam on the second line, right? Okay, so for this one, if you remember, for the functions, this star usually means the positional variables. So for the first one, it takes 1. So a will be 1, and for this one, it will assign 5 to b and 6 to c. So we have 1, 5, 6, and d will use just the default value 4. So 1, 5, 6, 4, the answer.
What's the difference between that and just writing f and 1, 5, 6? Without any
no, there is no difference.
Then why use that notation? Why use
So this was to test that you know this star, what this star means as an argument. But there might be cases that you just want to give the tuple or some sequence as an input, and you want your function to assign all the values in order.
You do like star argument, and then the argument is like a tuple that's like
exactly, yes. Right. Or it can be a dictionary, in which case you will use double star, and instead of entering each argument separately, you can just give the dictionary as an input, that will work. Okay, so that was the quiz. Okay, so today we will use both Notebook and PyCharm because we are going to talk about how to import modules. So last week we were just discussing this benchmarking interlude. So remember, I've been showing you how to test the performance of two different programs or functions to tell you one might be faster than the other one. So all these, this is actually a more complex case of what we have been discussing. But for this, let's actually create a file called timer0.py in our PyCharm and in the same directory. So in my case, for example, my project is lectures where I have all these IPython notebooks. And here I'm going to create a new file, which is going to be a Python file. And I'll call the timer0.py. And then I will have this function. Okay, so see, for example, here it's complaining. So complaining because I don't have two blank lines here. And here it's complaining because I don't have extra blank line at the end. So I do this. Can everybody see this, by the way? Should I increase it even more? You want me to increase? Okay. Is it better? Okay. Okay, so let's look at this function, what it is doing. So it has one input, which is a function, and also it takes some positional arguments. So it just takes all the arguments you assign in order, if you remember from last week or 2 weeks ago. And then we also import this time module, which we are going to use for timing our function. So this is actually, we have been using this a lot. So we assigned some start time as time.time. So that actually looks for the current time in your machine. And then we just run this 1,000 times. And we call our function, whatever function we want to test. And then we just input all the arguments, but we don't know how many arguments it's going to take, right? So this also answers your question about the quiz. We don't know how many arguments it will take, so we just input, we just use this star feature of Python. And then after running this function 1,000 times, we compute the time of current, we compute the current time, and then subtract the start time to get the total elapsed time in terms of seconds. Okay, so now I'm using IPython mostly just to actually just to run this code. So let's make this this way, so you know that I'm not running this. It's not a code. And here, so I want to call this timer function. By the way, how is the font of IPython notebook? Do you want me to increase it too? Yeah. Is it better? Okay. Okay, so now I want to import this timer function. So how do I do this? So in Python, since we are in the same repository, it shouldn't be a problem. But I'll tell you how to do if it's not in the current directory. But let's say everything is in our current working directory. So I can just say from timer 0, import timer. So it worked, okay? And now, so I want to use this timer function. If you remember, timer function takes function that you want to compute as the first input, and all the other inputs are going to be the arguments to that function. So in this case, I say timer, so function is power, and 2 is the first positional argument to your function, and 1000 is the second positional argument. But in this case, this will not work because, oh, actually it works, sorry. If we could have also said import timer 0, in that case, you will need to do timer 0 dot timer. But since we use this from statement, from timer 0 import timer, we don't need to do that. We don't need to say timer 0 dot timer, okay? So what this does is actually it calls power 2 to the 1000, 2 to the power of 1000, and it calls it 1000 times. I mean, maybe we shouldn't make it 1000. Let's make this one, I don't know, 4. So it calls 2 power 4 1000 times. Okay, and let's say how much, in terms of the seconds, how much time elapsed. So this much time. Okay. So if you are curious about what power was doing, what inputs it takes, you can take a look at this. So basically, we are just inputting x and y in this case. Okay. So for this one, we want to test another function. So in this case, this function is some string that's upper. So basically, we are just computing the uppercase of whatever input you give. Okay, so basically, if you have spam in lowercase, it will give you everything as uppercase. So here our input, our function is this, upper, and our argument is SPAM. So basically, it's going to return uppercase of S and P and A and M. And now, since we are doing timer, this is going to call this function, so spam.upper actually 1000 times. Basically, so this is the elapsed time that you get if you run this code 1000 times. Okay, so this sounds simple, right? So, and also makes sense, right? What we are doing. Actually, this is what we have been doing to compare different approaches so far. But there are some problems with this code. So first of all, it doesn't support keyword arguments in the tested function call. So it only assumes we only give everything in order, everything is positional. And also, it hard codes this repetition account. So 1000, it should also be adjustable. Users should be able to pick the repetition number as much as they want. And also, it only gives a total time, which might fluctuate on some on different machines, right? So sometimes your machine might be computing something else, so that time the performance might be lower, all that. So can we actually do this better? So now let's create another file, timer.py, in our PyCharm. Okay, now let's copy this and make this like this, so you know that I'm not running this here. Okay. And again, since it's complaining, I like to make it happy. So you just add extra blank lines. Why is it complaining? Remove redundant parentheses. See, so it says that this is better not to use parentheses. You know, so I'm actually trying to illustrate that using PyCharm really increases the quality of your code. Multiple, see, so it says multiple imports on one line. It's not a good practice. Do this way. It's better. I mean, even for the names of the variables, it actually says that there is some typo in the word, but it's okay. I'm fine with that. It's okay. Yes. Okay. So those are little things. All right. So it looks good. So let's see what this function does. So just at the top, basically, if you are running, if your system platform is Windows, so so you can pick time.clock. Otherwise, you can just use time.time, first of all. I don't know, I didn't try this in Windows. So in Windows, if you have an issue with the time.time, you can just use time.clock. Okay, so let's look at the first method, first function. So here, first of all, you can first look at the doc string of a function. You can make a doc string by just these triple quotes. So here it says that the total time to run function repetition time. So, okay, this is the repetition times, this is the function, and these should be the arguments to my function. Okay, that makes sense. And then here, I start a list, repetition list. But do I need that? Yeah, I don't think we need this. Well, okay. So let's get rid of this and change it with this. This is better. Okay, so basically we start the time, and so we have this for loop which is which has the iteration number as the repetitions that we have, and then we compute our function with the parameters with the arguments we input, both positional and keyword, and then after the for loop we just compute the elapsed time, and we also output the last result of this function. And here, actually, again, you don't, if you don't use this index I, you can just use this underscore that that will indicate that you are actually not using that index. So it looks better now. So this is the total, what total does, right? You input the repetition number, you input your function, you input your arguments, and it returns the elapsed time for that many iterations and also the latest result. All right, and we also have this function, best of, okay? And it takes the same inputs. So it takes the repetition number and the function and all the arguments. But this outputs the quickest function among all those repetition runs. And it returns the best time and last result. So let's see. So let's say I have this best as really large number, which doesn't good. So the actually best means that's the best iteration you had with this function. As you can tell, it's pretty big. So hopefully we do better than this. And then you start your for loop as many iterations as you assigned as the input. And then I have a start function here. I have start time. And then I call my function. And this is the elapsed time. And if elapsed time is less than best, then I assign elapsed to this best. So I basically just pick the iteration that ran fastest. Okay, and now when I return the best time, best elapsed time, and also the last result when I call the function. Okay, is this function clear to everyone? Any questions about what it is doing? Okay, so we talked about these two functions, two methods, total and best of. And we now also have best of total that actually takes repetition 1, repetition 2, function, and all the arguments to your function. It actually calls the best of function, basically best of function for repetition 1 assigns to this. And here, actually total is my function that I'm calling. So when I have total as a second argument in best of, I'm actually assigning this function to total. And then it runs for the total, and this repetition 2 becomes an argument to this best of. So now it replaces this repetition 2 with the value here. Okay? So total was this. So now, so for the best of, the second function becomes, we actually call total as a function to compute best of. Okay? So basically, so it computes the best of over repetitions 1 for the total. Okay? So there are, you can think like 2 for loops. From 2 for loops, you pick the best. Is it clear to everyone what this code is doing? Okay, we have this. So now let's import timer. Okay, and now since I imported it without using from, now when I call total, for example, I need to say timer.total. So timer.total is going to be, so 1000 is the repetition time that I want my function to run, and power is the function I'm interested in. 2 and 1000 are the arguments, and when I say just return me the first element, so it will only return the elapsed time. It doesn't return the result. So if we run this, okay, it works. And you can also do it without giving 0. Yes, okay. So this is 2 power 1000. Okay? And you can do this for different function too, of course, which just runs this string uppercase. Oh, okay. I know what happened. Yeah, I need this. See, it makes it spam. And so you can also call just the best of over 1000 iterations. And okay, that must be really, really fast. That doesn't even show. Timer best of. Okay, the other one was best of total. Or you can do it even more. So this will take some time. Okay, I mean, still fast. And here, what am I doing? Best of, so 50 is the number of repetitions. Total is the, actually it should be timer.total, is the function I want to run. And these are the inputs to the total, which means for total, run this 1000 times. And this is the function to run. And spam is the sequence that you want to apply this upper or string. Okay, again the same mistake. Okay, so it returns both the best result and also the output, the last output of the function. So since we were also calling this function, which also returns the elapsed time, and also output of that was this. And if you want to do timer best of total, so this is actually, so these two are exactly the same thing. I mean, yes, the values might differ a little bit, but you are basically calling the same thing between for this and these statements. Okay, just a different way of saying that. Okay, so we have our nice homegrown timer function that we can use to test our programs in terms of timing. But there is also a timeit module where you can actually easily import. And so here you can input, so you can say timeit.repeat, for example. You can give the statement that you want to run, and then you also have the number of how many what was number here? Okay, so let's see. Okay, it's obviously not very clear. So this is, so repeat is 5, number is 1 million. Okay, so for example, now I'm confused, right? I don't know what this number come from. I forgot, and the doc string was not really very representative. So what if I actually go here and say from timeit import repeat, okay, and then I go here, go to declaration. Okay, all right, so now I can see what that repeat function in timeit does. So here I look at, okay, number, default repeat. Okay, default number must be something. So let's look for that if it was used somewhere else. Okay, so timeit, so number is an input to this timeit. So repeat, okay, repeat is obvious. Timeit number, So, and if I go to this one, see, I'm getting like, I'm almost like debugging each method. And here, time number executions of the main statement. Okay, so I didn't like this module that much, as you can tell. Number of times. So okay, so I think this is the second repetition, like what we were trying to do. So there is one repeat and there is also another repeat. But this, you know, it shouldn't take this much to figure it out. So when I look at here, when I look at it here, it should be clear what it is doing. So clearly, it's not, you know, this is not something that you may really feel comfortable using. But anyway, so I just wanted to tell you it also exists, that, and I almost never use it either. We can just run. So it is the minimum of maybe. So if I didn't have minimum, for example, what does it return? Okay, so it returns 5. All right, so it runs this statement 100 times, and it repeats it 5 times. And now when I say min, it returns me the minimum elapsed time. All right. So, for example, for this one, so it runs it 1,000 times too, and then it gives you the elapsed time for this statement that you give here. Or for example, if there is some test case you want to do, you can also, you know, you can take a look and then play with this. But honestly, I actually prefer to use this kind of benchmark, sorry, not this one, the one that we just wrote better, because it's more clear. We know what the arguments are and what we're trying to do. All right, okay, so that was for the benchmarking. So let's talk about the modules. We just started touching the modules, right? So for example, here, this timer.py or timer0.py were both modules that we imported. So basically, they are just Python program files, and each file you can think it as a module. And modules also import other modules to use names that they defined. For example, here in this module timer, I'm also importing other modules, which are actually built-in modules. So basically, there are 3 things that you will use to interact with the module. So one is import that we just used, that lets an importer fetch a module as a whole. And from allows the clients to fetch particular names from a module. For example, when I say import timer, it actually fetches everything. But when I say from timer import timer method, then it only imports the method that I'm calling for. And also, you can also reload the modules, which is a way to reload a module code without stopping Python. Because if you don't do reload, it will just use what you initially imported. But here, so it says import lib, but there's some difference between Python 2 and Python 3. So in Python 3, it's actually imp reload. But we'll talk about it. So why should we use modules? So first of all, it's an easy way to organize components, right? So you don't want to have just one single file that does everything. So it actually makes your system, your program more self-contained. And so they have at least 3 roles. Code reuse, of course, like what we were discussing for methods too. You know, instead of rewriting everything. You just import the module you just wrote. And also, they also have this system namespace partitioning. Let's say I have one utility function in one directory, and I have another utility function in another directory, and you don't want them to conflict with each other. So it's better to organize them. And every time when you import a module, it actually comes with its own namespace. So you partition the namespace of your program. And also it's good for implementing shared services or data. So once you write your program or module, you can just send it to someone else, and then they can import it for their modules to share the service. Okay, so what about the Python programming architecture? So, of course, programs usually involve more than just one file, right? So one file is a module, but you have more of those. And Python actually fosters a modular program structure that groups functionality into some coherent and reusable units. So, for example, let's look at this picture. So we have this top-level module, A, that actually imports another module, B. And those two modules also interact with each other. And they might also import some standard library modules like time we just used now. But so when you actually run this, these modules are not really launched directly. Okay. So now let's make another file. Let's make this file B in this figure. So let's say new Python b.py. Okay, and I copy this. So basically, what this is doing is so it takes so we have a method called spam, which takes text, and it prints text and also spam, basically. So this is file B, and we can have another file, A, that imports this. Okay. New A.py. Okay, so what is this doing? So this imports file B, and then it runs the function spam with input Gambi, so that will print Gambi spam. Okay. So we have both A and B here. So this is actually one way. I mean, you can also import other things. For example, you can say import timer. You know, you can have something else like def my timer. What should we say? Or no, let's do something else. let's say name equals Stevens. Okay, and now, so let's run this one. It's so, let's run A. You can say run. So it said Gambi spam, for example. But if I also say print name here, and then in my code I say run A, so it prints Stevens, and also it prints whatever input I gave. But then okay, this is a little work on 551. So let's say I say import B. Oops, sorry, forgot to say IPython. So let's say import B. You probably cannot see, right? Okay, so import B. So it runs B from all the way. Oops, sorry. Okay, so it runs this module, but when I say import B again, it doesn't do it because it only imports once. So in order to do it again, you need to reload it. So basically, you need to know that they are really runtime operations. So there are some 3 distinct steps that first time when a program imports a given file. So first of all, it finds the modules file. So in our case, it wasn't a big deal because we are already operating in the same directory. So we didn't have any issues. And it also compiles it if needed. We didn't need it in our case. But it also runs the modules code to build the objects. So basically, once we say import B, it ran all these statements here. That's why it printed. All right. So the first one is the modules file. How to find the modules file. So if you want to import a file across directory boundaries, you need to know how the search path works and how to customize it. So roughly, Python's module search path is composed of the concatenation of these components. Some of are preset for you and some of which you need to modify. So when you do import, Python knows where to look. So first it looks for the home directory of the program, which was the case in our example. And also it looks for the Python path directories that you might have set. And also standard library directories. And also some content of path files, and also some side packages of some third-party extensions. So basically the first and third are defined automatically, but for the second and fourth, you need to include your own directories. Okay, so if you want to, yes.
I include the function, and why there's a white space between the text and the spans.
Oh, it is because of this print statement. For example, if you say print A, B, it's, you know, so when you print this way, it actually just adds a space.
Okay.
Yeah. I mean, if you don't want it, you can put a plus here. Okay. All right. So now let's talk about the systems path, where Python knows where to look for the modules you are importing. So in order to see that, you need to import this system module, and you can just print system path. So here you see these are all the paths that my Python installation is looking for. For example, yes, see, so for example, it is looking for my virtual environment EE5551. See, so apart from the current directory, almost all others include my virtual environment EE551. So that's actually why I was trying to tell you to use separate virtual environments for different projects, because if I'm working on this project, I want my Python's path to set up all this. So if you change one of these, you probably want to use a different virtual environment. That's actually why some of you were having troubles with the assignment, because you had a different system path, and it wasn't set correctly when you ran the other assignments. So it's probably better to have a different virtual environment for each assignment you are doing. Okay, so yeah, keep in mind that when we import, we don't actually add this py, the file extensions in Python. So let's move to module coding basics. So in order to define a module, you just simply use a text editor to type some Python code into a text file and save it with that py extension. And any such file is automatically considered a Python module, like what we just did here, right? With all these files we defined. So these are all modules. And for the module file names, so if it should end with .py suffix if you plan to import them. So for example, we can have another module, module1.py. We can create another one. Module1.py. And it has a printer method. So I define it here already. So my import should work. So basically I say import module1 and module1.printer. Okay. Couldn't find it. Oh, I have a typo with the name of the file. So you go and say refactor and rename. Okay, now let's try again. Okay. So again, another example for an import statement. And once I import it, I call the method printer, and this is the input to the printer. And this is an example to the from statement. You can say from module1 import printer, and it works again. So there is also a star statement in Python. So when you say from module1 import star, it imports everything you need. So let's see. Well, this is probably not going to work now because we already have defined printer here.
Wait, so the star knows like the functions you're trying to use, and then it imports the corresponding modules?
Yeah. So let's do this. So let's say a B, C, 5, 6, 7. Okay, so this is my module 1 py, and so I actually want to, I don't want to show the reload yet, so let's first all outputs. Let's clear all the outputs first. And now, so let's say, so now I have nothing in the memory. I cleared everything, okay? And I have this module 1 module, and I say module 1 import star. Hello world. So it finds it. But what else? Does it import something else? This is interesting. Okay, so import module 1, module 1 dot a. This is interesting. Why doesn't it run this? So we can actually fix it by defining underscore all, but let's not do that for now. But let's do this: print A, B, C, and so import module 1. Okay, I don't think it really cleared everything. Okay, I know the problem now. It's so it is still calling the first version. That's why. Let's reconnect. All right, so now let's try again. From module 1 import star. No, I think it's still calling the. All right, I'm gonna do this. From import reload module 1. Okay, now it's actually worked now. But okay, now it's worked. Okay, so let's do the. I just wanted not to remember. This is actually another reason I don't like IPython notebook. Shut down. Let's close this and start again. Okay. All right, so let's go to okay, we were talking about this star. From module 1 import star. Let's run this again. Okay, so okay, now it works now. It was an importing issue. So basically what I did here, to summarize, I have this module 1 that has this print method, and also has these variables A, B, C, 5, 6, 7. Okay, so when I say from module 1 import star, it imports everything. In addition to printer, it also imports A, B, all that. But you can see the danger with this, right? Because it might collapse with all the statement, all the other namespace in your work, and also you want to know where methods come from. For example, when you write a code, when you say from module 1 import printer, I know that if something is wrong with printer method, I can just go to module 1 and fix it. Or when I say import module 1 and then module 1.printer, I know where printer comes from. But in this case, if I keep doing this for all modules I'm using, no way I can know where these parameters A, B, or this function printer come from. So just be careful when you use this star statement. Or I almost never use it, honestly. Okay. So, but this one is not going to work because we didn't import module 1. We just use star for everything. Okay, so basically, I actually illustrated what I just did, but let's make sure we all understand this. So let's create a simple.py file that has, again, print and also spam values. So here I go and say new. Oops. Simple.py. Okay. So I have this. And so I say import simple. It runs the print here. And then I can also access the value of spam by saying spam simple.spam, which is 1. And now let's change the value of simple.spam to 2. And now let's import simple again. So when we import simple second time, do you think it's going to print hello again? No, right? Because as I said, so they happen only once. The import happens only once. So let's import it again. But so simple.spam, do you think the value is 2 now or 1? So original simple.spam was 1, and I changed it to 2. And then I import simple again, and now simple.spam. It's now 2. Because when it ran it, for the second time, it didn't do anything. We need to reload it to make it, again, 1. Because when you run import second time, the Python thinks that I already imported, I know what it is. I'm not going to go through it again, basically. Okay, but what if you have some changing mutables in the modules? Like, let's say I have this small.py file. Let's create one. Small.py. And here I have 2 variables, x and y. So now from this module small, I import x and y. And then I change the value of x to 42 and y0 to 42 too. Okay. So here x is not a shared mutable object. You know, numbers are immutable. And but y is a list, so it's a mutable object. So the names y in the importer and the importee both reference to the same list of the object. So changing it in one place will also change it in the other one. So now let's import small again. So small dot x didn't change, although we changed x here. But when we went through it, it didn't change. But small dot y, it changed because it's a mutable variable. Okay, let's back up. So what happened here? So we imported x and y from small, and we changed the values of x and y, where x is immutable, which was just a number, and we changed it to 42, and we changed y0 to 42. And then when we import small dot x actually didn't change. It's still 1. But small dot y has changed because we were using this immutable variable here, and changing it in one place changed it in other place too. So so as in other cases, you should be careful for the shared references again. Okay, so how are import and from equivalent to each other? So actually, I don't think we need to create files for this. So let's make them just text. So let's say you have a module called module, and you import two names, name1 and name2, to copy out these variables from the module. And you can use this without using from by just doing, you can say import my module and assign name1 to module name1 and name2 to module name2, and then you can delete the module later. So since I'm not running it, so let's make it this too. Okay, so this is how import and from are equivalent, or how you can make them equivalent. Okay. So when you import the module, when you say module.name1, it understands the variable you are asking for, and module.name2 will give you the variable name2 in that module. Okay. So when import is required, okay, so let's write this. So let's say functions 1 will print function of m, and this will print function of n, and let's create two files. So this will be the first file, new m.py. Okay, and let's create new n.py, and this will be function of n. Okay, so we have two functions with the same name, but different modules. And let's make this text. Okay, so in this case, from statement will fail, right? So let's say I have another file which is o.py. When I say from m import function, from n import function, so they will collide, right? So it will only call the function from n. So in this case, I mean, since I'm also not, so I'm not going to create another o.py file. I think this is clear what it is doing, right? see. All right. So in this case, import will make more sense here because you can include the name of the modules. For enclosing the module makes the two names unique. So for example, I can say import m. Actually, PyCharm complains when you write it that way, so it likes it separate imports, and you can run this, so it runs both function of m and function of n for both. So this is one example that you can prefer import to from. Or another way to solve this is you can also say, so from m import function as a different name. So you can give them different name to separate the namespaces. So for example, here I'm saying from m import function, but call it m function. And from n import function, but call it n function. And then I can just call m function and n function. Okay. All right, so what about the namespaces? So now let's create another module, module2.py. Okay, so what is this doing here? So we import something although we don't use it, and we have this variable name, and we have a function that does nothing, and we have a class also that does nothing, and then we print saying downloading. Okay, so now let's import this module. Okay, so it ran everything, all the print statements that we had here. And so the first time this module is imported, Python executes its statements from top to bottom. And again, just to repeat it, when you do it again, it doesn't run those statements again. So once the module is loaded, its scope becomes an attribute to the namespace in the module object we get from the first import. And now you can look at the attributes of this module 2, where it had name is 42. And why does it have two names? Or maybe, what if underscore name? You see? So it also knows the name of the file, or name of the module, sorry, which is the file. And you can also call the function. So this actually shows you the namespace of module 2 is pretty much separated. And you can access all the namespace dictionary by just running this underscore dict underscore, and you can say keys. And here, this actually has all the other attributes that your module has. But you can see we actually never defined these ones, but Python assigns them automatically. So like what I ran here, name, for example. So even if you don't really implement it, Python assigns a value to those. So most of the time when you see these underscore variables, that means you are not supposed to touch them much. You're not supposed to modify them. They are more like, almost like private attributes. Okay, so here, yeah, Python adds some names in the module space for us. So file gives the name of the file the module was loaded from, and name gives its name as known to importers. All right. And so we can also have this namespace nesting. So let's say I have module 3 where it has only x3. So let's say new Python file module3.py x is 3. And we have module2.py that imports module 3. So new So what it is doing is it has its own x, and it imports module 3, and it prints its own x, the global x here, and also, but this is global for this module, and it also prints the x that you imported from module 3, which was actually global here, but it comes as module 3.x here. Okay. And then let's say module 1 py new Python file 1.py. Okay, so now I'm importing module 2, and here I print x, which is the global x in this module, and I print x from module 2, and I can also print x from module 3, but for that I need to go through like module 2 module 3 x. So this is a nested namespace. So let's run this. Okay, so what happened here? So it imports module 2 first. So you go to module 2, but it imports module 3 first. You go to module 3. So okay, I have 3, and it prints 3 from. Sorry, first it prints 2 of this module, and then 3. So we have 2, 3, and then for module 1 it prints 1 here, and then 2 here, and 3 here. Okay, is that clear? So basically this is very clear, right? This one, 1, 2, 3, this line is clear. Where does 2, 3 come from? It comes from this import module 2 that runs this, where it is 2 and 3. Okay. 2 comes from this global x here, and 3 comes from module 3. And so let's run it again. Oh, so it is since in PyCharm it actually, I'm not doing it in an interactive way. It resets every time when I say run. But if I do it here, let's see. Let's say mode 1. Okay, and now let's. Okay, see, so this is another way you can run a Python code. So I run it for the first time. So it imported module 2 to 3, but for the second time, didn't do it, yeah. So it only printed whatever was in the code. Okay, is that clear? Okay, so that was all about namespace nesting of different modules. So what about reloading a module? So yeah, as we have seen, a module's code is run only once per process by default. So to force module code to be reloaded and rerun, you need to ask Python to do so explicitly by actually running this reload built-in function. Okay, I don't think I needed this. So, for example, so this is how you call it, but I don't want to make it a code for now, so let's keep it this way, just more like a reference. And now let's have this changer file, changer.py, that has all this. New Python files. Okay. So what does it do? It has this message, and then it has this method. The method just prints a message, which is not very interesting task. But anyway, so we can just import it. And then in order to run the printer, the method called printer, we need to say changer.printer. And so it just ran the message, which was first version. And now, so let's now go and change it. So let's say, let's make it after editing. So I'm gonna change this to, okay, so if I say import changer again, when I run a changer.printer, it is still printing the old version, although I changed it here. So if you want to force it to reload, so you say from import reload, and then you reload the changer, and then when you run it again, now it's updated. Now it's the message is after editing. Okay. All right, so in addition to module name, an import can also name a directory path. So a directory path Python is set to be a package. So such imports are known as package imports. So you usually don't have just one file in your system, right? So you have a directory that consists of files, and they have subdirectories and so on. So at a base level, package imports are straightforward. So all you need to do is you say import directory 1, directory 2, and module. Or you can also do from directory 1, directory 2, module import X. So let's assume here X is a method or some variable, anything. Okay, so these two import statements, these two, imply a directory structure that looks something like this. So you have some root directory, directory 0, and directory 1, directory 2, and you have some module under directory 2. So the container directory, directory 0, needs to be added to your module search path unless it's the home directory of the top level. So in this case, for example, if if directory 0 is not in my search path, then this wouldn't work. So here I'm assuming that the container directory 0, is already in my search path, so Python finds it easily and then goes through its subdirectories. But another important thing you need to keep in mind is that you need to add init files. So it is underscore init files. So the directory structure should be, so let's say we have all these directory 0, directory 1, directory 2, and module, and the import statement of the form import this. You actually need to apply these rules. So first of all, those subdirectories, directory 1 and directory 2, both must contain init files. They can be even empty, but you need, so Python needs them in order to propagate through directory 1, directory 2. But directory 0, the container we call, does not require this init file because it's already in our search path. And yeah, so directory 0 must be listed in the module search path or system path. Okay, but so all you need to do is you need to add this directory 0 to your search path. But for all the others, you don't need to add them to the search path, but all you need to do is you can just add a init file. So basically, this is the net effect of this example. So you have this directory 0, which is the container on module search path, and you have the directory 1, which is init file, and you have another directory 2, which also has a init file. Okay, it should be like this. Okay. So basically, the init files can contain some Python code, like just normal module files, but their names are special because their code is run automatically the first time a Python program imports a directory, and serves primarily as a hook for performing initialization steps required for your package. So okay, so let's create this directory 1 and then directory 2. Okay, so in PyCharm, new directory. So I'm gonna call it directory 1. And inside that directory, I'm going to create another directory 2. And in directory 2, I'm going to create a module, mod.py. So here, let's go new .py. And I have this. Okay, so I'm in my current directory, and I have this directory 1, directory 2, and directory 2 has the module file. Okay, so now let's say this will work. This is strange. I didn't add init files. Okay, this is strange that it was able to import it, although I didn't add the init files. Let's also create an init file. So under directory. Yeah, in these kinds of things, there are lots of differences between Python 2 and Python 3. Okay. And so let's have init file in directory 2.2. init.py. All right. Now, since we already imported, it might complain. Let's use reload now. From import reload. Oh. Okay, this is interesting. Why it is not reloading? Close this. Okay, so let's try it again. Oh, but how come it still remembers? Yes, it still remembers. Sorry, it is. I'm trying to show that those init files are run automatically, but keeps remembering the module. Okay, so this one. Oh, okay. Yeah. So finally, when you run, when you import from directories, it actually went through all the. It automatically runs the init files that corresponds to the package. So, for example, for directory 1, it is init file that just prints directory init, and then the other one just prints directory 2 init. And then for the module, it prints in module.py. But when you do it second time, it doesn't do any of those. So basically, when you include the init files, that runs it automatically every time when you import that directory. But before, in order to run this module, you had to have init files. And this time it worked even without the init files. So that's something I wasn't expecting. But as I said, yeah, Python is changing really fast. So there are so many changes between 2 and 3 in terms of these imports. So yeah, so you need to make sure that you need init files or not in your version. Okay. Oh, just like module files, we can also reload the directory 1 and directory 2 again. Okay, but so this time, how come it worked this time? Second attempt. So I edit it, and then I reload it. Okay, now it's reloaded. All right, so basically, you reload directory 1 and directory 2, directory 1.directory 2. All right, so let's look at the namespace of this. So with directory 1, you can say, so it actually just returns the name of the file, of the module. And then this is the another one. And we know this is still a module. And we know that directory 1 actually has this X, which is already in the init file of directory 1. So whatever you had in the init file corresponds to the namespace for directory 1. That's why it knows directory 1.x is 1. And when you run directory 1.directory2.y, so that directory 2 has this init file where y is 2, and when you run it, knows it's 2. And you can also access the modules file by running this. So directory 1, directory 2, and module.z. So in our case, z was 3, which was here in this module. Okay. So what about from versus import with packages? So import statements can be a little bit inconvenient to use with packages because you may have to retype the paths all the time you do something, right? So for example, in this case, in order to ask for the value of z, you have to go through directory 1.directory2.module, all that. So you don't want to do that all the time. So in such cases, it's actually easier to use just from statements. So for example, we can say from directory 1.directory2 import module. And in this case, we don't really need to repeat the path. We don't need to type directory 1.directory2. We can just say module.c if you want to access the value of that. Or you can just get the value of z by saying from directory 1, 2, and module. Or you can also change, so you can also import everything with a different name, which is module, which is shorter than the name. Or so this is another way you actually say from all this import z as mod z. So all these are different versions of importing packages. So the only time package imports are actually required is to resolve some ambiguities that may arise when multiple programs with same name files are installed on a single machine. So let's say you're a software developer and you have this system1 directory where you have all these 3 functions, where the utilities is the common utility functions and classes, and you have this main that launches this to start the program, and you also have this other that import utilities to load to my tools. And now suppose there is a second programmer who also develops a different program with files also called utilities and main. So you can assume these are really generic names, right? It's very common that 2 programmers can call same name as utilities or other or main to the files for different tasks. So far there's no problem. Both systems can coexist. So you can have this system1 directory and system2 directory. But suppose after you install these 2 programs on your machine, you decide that you'd like to use some of the code in each of the utilities.py files in a system. So if you say import utilities and you say utilities.function or call it, then it's not really clear which one you are using, right? So the actually Python picks whatever directory appears first in the system path to import these utilities. So you can actually fix this by having this root directory where you have this system1 and system2, and also system3 can be your directory where you put your new code and you work with both of these packages, system1 and system2. And in that case, you can say import system1.utilities and import system2.utilities, and so you can actually call each function separately. So for that, it's probably better to have such a kind of home directory for all these packages. All right, so what about relative imports? So rather than listing package import paths, imports within the package can be relative to the package too. For example, when you say import dot string from dot string, you are importing the string module from the current directory. So let's say you are in my package. Sorry. I want it to appear here. Anyway, just to know that this is not a code. Anyway, so I'm just trying to show that this was a command, but doesn't let me do it. Or you can say from current directory import string. So it actually imports the my package.string. Let's say you are in this directory my package. Or when you say double dot, from double dot import string, it actually imports the string sibling of my package. So it goes to the parent of your current directory to import it. So you can use this for relative imports too. So let's say you have this directory, my package, where you have your init file, you have main module, and you have string module. So when you say import string, Python actually imports the string module, the built-in module first. And when you also say from string import name, it also imports the name from string outside of the package. But if you really want to import this string that's in your current directory, you say from dot import string. that imports the my package.string here. So this is the relative. Because, you know, string is a common, it's a built-in module, and Python will first look for the built-in one before your own. So you may need to use relative imports for those kinds of cases. Or again, like with some double dots import spam, it also imports a string of my package. Okay, so as a summary, so this figure sketches the environment in which the modules operate. So let's say, this is a little big. So let's say you can have modules where you have variables and functions. Each of functions can have variables, and you might also have classes, which we'll start discussing next week. And you can import other modules. You can access the variables and functions and classes of other modules too, and those other modules can also import some other modules. But they all have their own namespaces. Okay, so now let's try something different. So Python also has this single underscore to prevent these variables from being copying out when a client imports. So let's say let's define this unders.py file where we have this we have variables with underscore. What was the name? Unders.py. So it has variables, and some of them have underscore here. So, you know, Python underscore at the beginning of your variable has a special meaning for Python. So when we say from unders import star, I didn't save it. Unders.py. Oh, I saved it to a wrong directory. See, it saved it to directory 2. That's why it couldn't find it. So I need to put it to... Okay, maybe this... Okay, so I put it under lectures, so delete it from here. Okay, now import it again. Okay, now it works. So let's see, I can access the values of AC, and for underscore B, it complains.
How can I know what the current directory is?
So in my case, I'm working in this IPython notebook, right? So I know you can write pwd. So this is my current directory.
But if I want to change my current directories,
Yeah, you can do cd, the run, all that. Okay, so here, so this was interesting. Again, we had this unders.py module where we had these 4 variables, a, underscore b, c, underscore d. And when we say from unders import star, it only imported a and c. It didn't import underscore b. So Python actually hides them from the client, where I'm the client now, who imports unders. But what if you import unders? So in this case, it comes with all the imports. You know, so when you use this star, so Python actually knows that it can be dangerous to have star. So it prevents those special variables from you, basically. Or alternatively, you can achieve a hiding effect similar to the this underscore x, yeah, so underscore x naming convention by assigning a list of variable names, name strings to the variable underscore underscore all underscore underscore at the top of your module. So basically, when I define this, then all these variables will have precedence over underscore. So let's call this alls.py. Let's create alls.py function. Okay, I have this. And when I say from alls import star, so in this case, you think we will have access to underscore c? We will, right? We just mentioned that once you have this underscore underscore all, then Python knows that, oh, okay, in this case, the variables that start with underscore are probably needed, so I'm going to return them to the client. But in this case, B, do you think B will be printed? No, right? Because B is not in this list of alls. So it complains. But with the other imports, you can still get all those. So you can say from alls, import everything, and it just works. Or when you say import alls, it actually gives you all that alls A, alls B, all the variables that you need. Okay, so Python also has this underscore underscore feature as an import. So for example, let's say you are working in Python 2 and you want the division from Python 3, you can basically say from underscore underscore feature underscore underscore import division. This is actually, so the reason why we have this feature module is because, as I said, Python is developing really fast, and there are so many differences between Python 2 and 3. That's why you may want to use some modules from the next version. And also, so these underscore underscore name and also main also have special meaning. So each module has a built-in attribute name, which Python creates and assigns automatically. So if the file is being run as a top-level program, then this name is set to string main. But if it is being imported, then the name will set to module's name as known by its clients. So, for example, let's define this function or this module run me.py. Okay. Okay, so basically in this module, what I'm saying is I have this method called tester, and if the name of this module is equal to main, then run this tester. Otherwise, don't do anything. So for example, if I run this in PyCharm by just doing this, oh, sorry. Ran the wrong one. Okay, so it prints it's Christmas in heaven because it knows that name is main, because I'm running this, I'm operating on this module. But what if I say import run me here? It didn't really run this tester, it didn't really print it. But if I say run me, this is almost what I did here. So in that case, Python knows that, really? Let's see this. Oh, because you made me change the directory. Yeah. Okay, so now let's say run me. Now it actually prints it. Okay, but when you say import run me, it doesn't print it because when you're just importing it, it knows that the name is not main, so it doesn't run this. But when you run it directly as a top level file, it knows that it assigns the main to the name, then it runs this method. Okay, so was this clear? Name and main. Okay, so you can also add some doc strings to your module to make it more readable or understandable. So you can document. So basically, you can just say, for example, I import this permit that we discussed last week. I can just say help permit. It actually gives me the details about it. Or I can say so let's say this is a doc string, okay, and let's reload run me and say help run me. Okay, so it's actually here I describe it with this string I put at the top, and then when I run help, it actually gives me the information. All right, so what about the changing the module search path? So let's say you have this system path where you have all these paths that your Python is looking for, the module that you are importing. Then if let's say you want to append another file or another directory, you just call users whatever directory you actually want to say, you say system.path.append. So this is the output of path is just the list. So you just append a value to that list. And then once you have it, then when you have system path, see it's actually added my my directory there. But next time when I start IPython notebook, it will not remember it. So if you need to change it, you will need to do this all the time, or you need to modify Python path, which might be dangerous sometimes. Okay, I can skip this. All right, so next topic is object-oriented programming, which is so we will start with the classes and all that next week. So before closing, so let's finish with the quiz.